In this second demo, we have a very endothermic reaction, okay? So what we are going to look at is we're going to look at some barium hydroxide and some ammonium nitrate, and when they react, they produce ammonia, which is a pretty horrible gas, and some water. So what we see, you'll notice these are two white solids, and the fact that water is going to be produced, we should start to see it become sort of slushy. The other thing we're going to do, because it's quite an endothermic reaction, is to demonstrate just how cold it gets. I'm going to put a little bit of water on this piece of wood, just a small amount. Okay, and hopefully we can get it to freeze just from this reaction. Okay, so I'm going to place the ammonium nitrate, let's take that off, onto there. Okay, and the water is underneath. Okay, and I'm going to add my barium hydroxide. And this is not quite as exciting as the last demo. We're going to add those two together. Again, both white powders. Okay, and we'll start stirring them together. Okay, now I know obviously you can't tell from the video, but I'm starting to be able to smell the ammonia being given off. And you can see it's starting, and then my hands are kind of in the way. It's starting to sort of slush together, become very sort of slushy. And that's because of the water being produced. So sort of ending up with sort of a paste. Let's break up the bigger chunks. So it's almost sort of toothpaste consistency now. So I started off as two white powders, and now I'm sort of much closer to sort of toothpaste. Okay, so I'd say that's probably as mixed as it's going to get. And again, the ammonia, you can really smell the ammonia. So it's definitely, quite a lot of evidence to say that there is a reaction going on. But we're not really interested in there being a reaction going on. We're interested in proving that it's endothermic. Okay, so if I sort of bring the camera closer, you should be able to see that in there we now have this sort of slush. Well, we started with two white powders and now we sort of have this slush. So I'm going to grab a thermometer quickly. And we'll just pop that in there, just bring it all to one place. Just have a look at that thermometer. And we should see that it is dropping. Use the thermometer, stir it around a little bit. So again, so while we're waiting for that, if we look at the reaction profile diagram for this reaction, okay, zoom back out a little bit. What we should see is that the products are higher in energy than the reactants, and therefore they need to take energy in from the surroundings in order to do that. So this is an example of an endothermic reaction, a reaction that's taking energy in from the surroundings. And you can identify endothermic reactions very quickly by reactions that have a decrease in temperature. Okay, so reactions that decrease in temperature are endothermic, and reactions that increase in temperature are exothermic, because in exothermic reactions they're giving energy to the surroundings, and in endothermic they're taking energy in from the surroundings. So hopefully, if we zoom back in on our reaction, you can see that the temperature has dropped to just above 10 degrees. Okay,